Chapter 2, Understanding the Weather. A change in the weather is sufficient to create the world and oneself anew. This is a statement given by a French novelist. So, in this chapter, Understanding the Weather, we will be dealing with these two main questions. That is, how can we measure and monitor the weather around us, and how do weather predictions help us to prepare for events like heavy rain, storms, drought, and heat waves. So first we'll study about what is weather and what are its elements. So you wake up one winter morning and shiver, and you reach out for thick clothes to keep yourself warm. And in the summer, you choose clothes that keep you cool and comfortable. So you are responding to your body's signals, and your body is sensing the weather. So in winter and summer, we have different kinds of clothing. And the rainy season, we adapt by using umbrellas and raincoats. So according to the climate or weather around us, we start responding and adapt for us to actually survive in different weather conditions. So we are responding to our body's signals, and our body is sensing the outside weather. So first we'll understand what is weather. So weather is a state of Earth's atmosphere at a particular time and place. So weather is a state of Earth's atmosphere at a particular time and place. So what is atmosphere? So in simple terms, it is a layer of gas that surrounds around some planets. That is in case of our Earth as well, and we call these gases air. So this is Earth, and the gases which are surrounding or on top of the Earth's surface are the gases which we call the air, and these are called atmosphere. So the Earth's atmosphere may be compared to a cake with several layers. So we have troposphere, tropopause, and the ozone layer in between, a stratosphere, and many more on top. So these are various layers. We'll read one by one. So the layer closest to the surface of the Earth is called the troposphere. So the one which is closest to the Earth. So the first layer which is closest to the Earth is troposphere, and that is where all the land-based plants and animals, including we humans, live and breathe. So it is where almost all the weather phenomena which we'll explore in this chapter will take place. So firstly, in this chapter we are going to focus on the first layer and what are all the weather phenomena happening in this place. So the troposphere extends to a height of 6 to 18 kilometers from the ground. So from 6 to 18 kilometers, and it is less thick at the poles. So this is the Earth, and we have both North Pole and South Pole, and its atmosphere will be thin in the poles and it will be thick in the tropical regions where we have the warmer air expands. So we'll study more about this other layers in your science classes. So for until here we'll confine to studying about troposphere, but we have other layers as well, that is tropopause, stratosphere, and ozone layer in between, and many more. So we use many words to actually know what is weather, like hot, cold, rainy, cloudy, humid, snowy, windy, and so on. So this will be, we express all these in different ways in which we experience the elements of weather. So first, the elements of weather. So according to all these parameters, we'll know actually what, either it is windy or it's cloudy, rainy, sunny, or anything. So the first one is the temperature. So how hot or cold the atmosphere is. Next is the precipitation. Next element is precipitation. That is any form of water such as rain, snow, sleet, or hail that falls from the sky is called the precipitation. Basically it is raining. So rain can be of snow, sleet, hail that falls from the sky. Sleet is frozen or partly frozen air, rain. Next, atmospheric pressure. That is the weight of air above us that is felt on the Earth's surface. So atmospheric pressure is the pressure of atmosphere, that is the weight of the air above us. Next element is wind. That is, the movement of air is called wind. Movement of air is called wind, including its speed and the path it follows. Next element is humidity. That is the amount of water vapor in the air. So humidity is the amount of water vapor which is present in the air. So mostly the coastal regions are said to be more humid in comparison to the tropical regions. So as you can see, it could be difficult for Krishnan. So they have given us a case study, that is, let us imagine that Krishnan from Chennai is speaking with Amir in Kashmir. So Krishnan tells Amir that it has become chilly in Chennai after it rained the previous night. Amir asks how cold it is. So how will Krishnan explain to Amir how cold it is? After all, what is cold for Krishnan may not be quite pleasant for Amir. So it could be difficult for Krishnan to convey his sense of chillness to Amir unless there is a commonly agreed way to measure the temperatures. So we have Celsius or Fahrenheit or any measure, then Krishnan will be able to convey Amir how chilly it is in Chennai. So it's the same with the other elements as well. That is how much atmospheric pressure, how much is the humidity, and all these elements. So in this chapter we learn how to measure these various standards. So how to measure all of these elements like the temperature, precipitation, pressure, wind, humidity, and all these elements. So from early times, humans have closely observed nature and learned to read the signals to forecast, that is to predict something which is going to happen in advance. So what happens in future, we are going to predict it at present. That is forecast, weather forecasting. So observing the birds flying low, ants carrying eggs, squirrels gathering nuts, fruits croaking loudly, frogs croaking loudly, or even the opening and closing of pine cones provided us valuable information about the coming rains or storms. So when we observe nature closely, we get many clues. So this knowledge has been passed down from generation to generation, and even now in many parts of India, people use traditional ways to predict the weather, especially that is the arrival of monsoon. So we have traditional ways of predicting weather. So in the last few generations, scientists have worked out methods to measure and monitor the elements of weather with great precision. So the traditional methods can't be very accurate, but if we have some scientific evidences and the tools to measure, then it becomes more evident. That is how scientists have worked on this and found out the monitors and many other things to actually evaluate the elements of weather. So based on these inputs, meteorologists try to predict how the weather will behave in a particular region after a few hours or a few days or even a few weeks. But how do they do it? Do they just look up at the sky and guess? No. So they will have to get some cool gadgets, and a few of which we will now look in this chapter. So the first, that is, we'll study about the weather instruments. First element is the temperature. So in your grade 6 science textbook, you have read about different types of thermometers used for measuring the temperature. That is, we have clinical thermometers and laboratory thermometers. And we have also learnt about the temperature scales, and one of them is the Celsius and the other is the Fahrenheit. So if for instance we have some cool temperature, that is 15 degrees Celsius, then it is noted as follows, and it is the same as 59 degrees in Fahrenheit. We also knew the conversions as well. So there are several types of thermometers. Some simply measure the ambient temperature, that is one of the immediate surroundings. So what is around us, that is the ambient temperature, and others record the maximum and the minimum temperature during a day. So the thermometers often use a colored liquid which expands when the temperature will increase. However, more and more digital thermometers are preferred as they are more precise and can record more data. So we have liquid thermometers, but now more and more digital thermometers are preferred. So indeed, temperature recordings can be used to collect some useful statistics, including the range of temperature or the maximum temperature minus the minimum temperature during a particular period. Usually it is taken to be 24 hours. So with the statistics, we can calculate the range of temperature, what can be the highest, what can be the lowest, and how can we expect in that 24 hours. And also the mean daily temperature or the maximum temperature plus the minimum temperature of the day, which is divided by 2. So we can calculate the range of temperature or the mean daily temperature, that is also called, or we can say it to be as the average temperature. Next is the precipitation. Next element of weather is precipitation. So if the news says that the particular place received 30 mm of rainfall in a day, what do you think? How is rainfall measured? So the amount of rainfall is measured with the help of an instrument which is called the rain gauge. So for measuring the temperature, we will use a thermometer. For measuring the precipitation, we will use an instrument called rain gauge. And when it rains, the water funnel falls into the funnel and is collected in a cylinder. So this is the rain gauge. You can see that when it rains, the water falls into the funnel and it is collected in the cylinder. And a scale is attached to the cylinder to collect the depth of the rainwater collected. For example, when the height of this water collected will be 5 mm, then we can say that the area received 5 mm of rainfall. Next element is atmospheric pressure. So for we have seen for the temperature we'll use thermometer, and for precipitation we'll use rain gauge, and next is the atmospheric pressure. So our bodies are quite aware of temperature and rainfall, but you may have also experienced that the weather sometimes feels heavy, as that is before a thunderstorm. So this is related to the atmospheric pressure, which is the pressure exerted by the weight of the air above or around us. So the atmospheric pressure is higher near the sea coast. So atmospheric pressure will be higher near the sea coast and lower as we go higher up to the mountains. So when you climb a mountain, the air gets thinner than in the plain below. As a result, the air pressure is low and there is less oxygen available for your lungs to take in. So when you move up altitude wise, if you go up and climb a mountain, then you can see that the air pressure will be less at the top of the mountain. That is why oxygen content will be less and it will be difficult for breathing. So with this less oxygen getting into your blood, your body has to work harder to keep you moving. So that's why people sometimes feel breathlessness or tired at higher altitudes, because oxygen content will be less, so less energy can be generated. So this will not mean that the atmospheric pressure is always high in the plain below or on the coast. In fact, in sometimes drops dramatically, resulting in what meteorologists called a depression. So it's not always that plains have a very high atmospheric pressure. It can also reduce, that is low pressure system, which can sometimes develop into a storm or even a volcano. So the instrument used to measure the atmospheric pressure is a barometer. So for atmospheric pressure we use barometer. So as with the thermometers, there are several kinds of barometers as well. So the unit they actually show is millibar, which is abbreviated as MB, and the normal atmospheric pressure at the sea coast is some 1013 MB, and the pressure below 1000 MB indicates a depression, that is low pressure system. So usually at the sea coast we find it to be 011013 MB, and something below 1000 MB indicates as a low pressure system. Next element is wind. So wind is the movement of air. Moving air is called wind, from areas of high pressure to the areas of low pressure. So speed and the path are the two important factors when we actually try to understand wind. So when we try to understand wind, speed and the path are two important factors. So the wind is an important element of weather, and its path and speed help us in weather forecasting. So air pilots and sailors need to be aware of wind data, as the wind has a great influence on flying or sailing. Farmers also use the wind path to actually predict where rain might come from, and also a greater wind speed can cause the soil to dry faster. So how do we measure the speed and the path? So a wind vane or a wind vane, weather vane, has a rotating arm with a pointer at one end and a tail at the other. So when the wind blows, this is pushed and the pointer will turn in the path of the wind. So this responds even to a slight breeze. So with this, they'll be able to find the speed and the direction of wind. So if it is moving slowly, then the speed is slow. If it's moving fastly, then the speed is more. So this is the wind vane and this is the anemometer. So the wind vane on a tarmac is called windsock, and it gives pilots an indication of the direction of wind during the takeoff and landing. And similar socks are used in industries that release air or gases. The simplest instrument to measure the wind direction and speed is the anemometer. To measure it using instruments, that is the anemometer. So it has 3 or 4 metal cups that rotate on a vertical shaft. When the wind blows, and the stronger wind, the faster the rotation. So a meter attached at the bottom counts how many times the anemometer spins in a certain period of time and calculates the wind speed in kilometers per hour. So it calculates the speed of wind in kilometers per hour. So if the movement is more, then the speed is more. If the movement is less, then the speed is less. Next element is humidity. Humidity is the last element of the weather on our list. So you already studied about the temperature, atmospheric pressure, wind and precipitation, and now we'll be studying about humidity. So it refers to the amount of water vapor present in the air, and it also depends on factors like temperature, wind, pressure and the location. So we can answer these questions more precisely by learning how to measure the humidity. So humidity of air is measured as a relative humidity, that is air that could contain absolutely no water vapor, which is impossible in natural conditions. So to measure the humidity, we actually assume a relative humidity, that is a place where no water vapor can be found. So this is not naturally possible, but it is rated as 0%, while air saturated with water vapor will have a humidity of 100%. So in practice, dry weather has a relative humidity range in between 20 and 40%, and while a humid weather usually falls in between 60 and 80% relative humidity. But how do we measure such numbers? So this is done through an instrument which is called hygrometer. Again, there are several types of hygrometers depending on the principle they are based on. So the measurement of the humidity is of great importance in many industrial processes such as food processing. So measuring this humidity is very important in many industries. One such is food processing. So museums also monitor the humidity as they need to maintain a dry environment to preserve their exhibits. So even museums need to study humidity and monitor it. So the weather stations. So as you can see that you need several instruments to measure the weather at a particular place and time. So they can be thermometers, and we have anemometers, and many more instruments are used to measure the weather itself. So a weather station brings all these instruments together, making it easy to measure and track the weather. So readings of all the measurements are taken on regular intervals, which helps in mapping and forecasting the weather in advance. So an automated weather station, AWS, is a self-operating system which uses several sensors to measure and record weather data such as temperature, humidity, wind, speed, the path, precipitation, atmospheric pressure. So such stations are widely used in fields like agriculture, aviation, navigation, environmental monitoring, and so on, providing accurate and timely weather informations without the need for human intervention. So when it is automated means there is no human intervention, and even the data will be more precise and more accurate, and it is used in various fields like agriculture, aviation, navigation, environmental monitoring, so that people can be known about, or they know about the forecast, so that they know how to adapt to what is going to happen. Next is predicting the weather. So meteorologists collect data using these instruments over long periods of time, and they study the data and use scientific methods to try and predict the weather. Such predictions are very important nowadays as climate change make extreme weather such as drought, floods, cyclones are becoming more frequent. So accurate predictions help us to get ready for such events, and they also enable the local governments to mobilize resources and prepare for any other damages. So for example, if stormy weather is expected at sea, fishermen are warned about venturing out in their boats, or an entire coastal area might have to be evacuated if a cyclone is expected. So that measures can be taken to avoid losses. So in this chapter, we have studied that the temperature, humidity, precipitation, wind, and atmospheric pressure together define the weather of any particular place. These are all the elements of weather, and the conditions of these elements is measured using special instruments, and data collected from these help us to monitor and predict the weather. And in different periods of time or situations, one of these elements is dominant. For example, rainfall in July, the temperature in May and any other month, and atmospheric pressure when a cyclone is moving, and the wind when a low, that is strong, hot, and winds that blow in North India in summers is blowing, or forest fires are spreading. So at one point of time, only one element will be more dominant. So if you see a rainfall, then humidity will be the highest. So that is how at one particular time one element will be the dominant. If we study that, we'll understand the weather in that particular place. And the weather is closely linked to climate. So we will study about climate in our next chapter.